All right, gang. I want to take a look at a couple more of these problems like we did in the videos yesterday. So why don't we start with these top two. Okay, so take a look at that first one. Okay, and remember it's the outside-inside roll, the chain roll. So I got to start with, okay, this outside exponent, and so my u has to be everything in there. Okay, so you have to start with u equals tangent of 8 minus 5x, okay, like that. Okay, so when I take this derivative, I'm going to get d dx, okay, of u to the third. Okay, so that's going to give me 3u squared times du dx, okay? And then when I put my u back in there, I'm going to get 3 times the quantity of tangent of 8 minus 5x squared times the derivative, okay, of tangent of 8 minus 5x, right there. Okay, so this part of it's done right here, and now I've got to do this part. And again, we've got to use the chain rule again. Okay, so right here to do this, we let u equal 8 minus 5x. Okay, so I just bring this guy down. Okay, now I take the derivative, okay, of the tangent of u. Okay, so it's going to give me secant squared of u times du dx, like that. Okay, remember tangent, derivative of tangent is secant squared. Okay, so let's see. I'm going to start substituting things back in and start to clean things up. And notice right here, if you have tangent of this whole thing squared, I can get rid of that outside set of parentheses if I want and write it as 3 times tangent squared of 8 minus 5x. Or you could leave it the way it is, that's okay. Okay, then it'd be secant squared of my u, 8 minus 5x, okay, times the derivative of u, which would be negative 5, like that. Okay, so my final answer, multiply that negative 5 into 3, negative 15 tangent squared of 8 minus 5x times secant squared of 8 minus 5x. And I don't see anything we could possibly do. Okay, because let's see, tangent squared, that would be sine squared over cosine squared. Secant would be 1 over cosine squared, so there's no way I can get anything to cancel off, so we just stay right here with this. Okay, so far so good. Okay, let's check out that second one. Okay. All right, so again, just like the first one, you start outside, work inside. Okay, so the very first thing we'll do, okay, is deal with this exponent of 3 on the outside, so u would be everything inside. Okay, so u is going to be secant, okay, of 12x squared, like that. Okay, so I'm going to get d dx, okay, that would be of u cubed. Okay, so I'm going to get 3u squared times du dx, and we go ahead and substitute back in, so I get 3, okay, here's my u right here, secant of 12x squared like this. Okay, let's see, I need one more set of parentheses right here, okay, to go with that starting one, like that. Okay, now we're good. Times the derivative, okay, of my u, secant of 12x squared. Okay, so again, I'm going to have to use, okay, the chain rule here, and this will be my u right there. Okay. All right, so let's see, I can start cleaning this up. the second power of secant of 12x squared, I could write that as secant squared of 12x squared, like that. Okay, then let's see. If I'm taking the derivative of secant of u, okay, it's going to be secant of u, tangent of u, times the derivative of u, du dx, like that. Okay. All right, so 3 secant squared of 12x squared. Okay, now notice my u right here, okay, is 12x squared, so I'd get secant of 12x squared times tangent of 12x squared times the derivative of 12x squared, which would be 24x. Okay, well, it looks like we're in good shape here. Now it's just a matter of just cleaning things up, okay? So let's see, I would take the 3 and the 24x and multiply them. So that is going to give us 72x right there. And then notice how I luck out here, and I have that, and I have that. And notice they're both secant of the same thing. So that would give me secant cubed of 12x squared. And then I have this tangent of 12x squared. Okay, and let's see, can I simplify that at all? Well, that'd be sine over cosine, and that'd be 1 over cosine, so I can't do anything with it. So it looks like this is my final answer, and we're going to check.